been exposed to the concrete protective liner industry in some capacity for over 20 years now, but taking a more involved role over these last few years. Predl has been innovating in this industry for 30 plus years, and recently they have brought their know-how and line of engineered products and support to the US. I'm very proud to be part of Team Predl as their business operations manager in Jasper, Georgia. Today we're going to talk about the reasons why we rehab manholes, some of the more common rehab options and issues with those options, and then we're going to dive into the Flexliner and the advantages and features of the Flexliner, followed by a case study of a recent installation video that outlines installation of the Flexliner, and then we'll wrap up with a question and answer session. Please feel free throughout the webinar to type in any questions you have. I don't want anybody to forget any important questions. And I will have some of my amazing colleagues from Predl Europe on the line and available to help answer any questions in case you manage to stump me today. So it's important for us to understand why we need to rehabilitate manholes. Currently in the United States, we have many sewer lines and manholes in operation that are well over 100 years old. So as you can imagine, that leaves us with a tremendous number of failing manholes in our sewer systems. Currently, the EPA estimates that we've got about 20 million manholes in the US in operation, and of those, 80% are in some state of disrepair. By not addressing those problematic manholes, we increase the risk of infiltration, which overwhelms our sewer systems, exfiltration, which allows sewage to potentially get into our groundwater, sewer overflows, which get into our streets and our public and our waterways, and in extreme cases, manhole collapse. The main culprit behind manhole degradation is biogenic sulfide corrosion, or as it's more commonly known, microbial-induced corrosion, or MIC. And this comes in the form of H2S, or hydrogen sulfide, and sulfuric acid. So this is a mediated process in which sulfur that occurs in the sewage is reduced by sulfur-reducing bacteria, causing the formation of hydrogen sulfide. And we all recognize that by that familiar rotten egg smell. So once this process has occurred, the sulfur is then further oxidized by Theobacillus, and that's another bacterium. So when this occurs, we've got the hydrogen sulfide gas converts into sulfuric acid. And I wanted to go through this briefly because it's important to understand that these reactions mean we're not safe from corrosion either above or below the line of sewage. Infiltration and exfiltration can occur anywhere we have cracks in the original structure. This can be caused from subsidence from traffic loading, the invasion of roots, presence of severe corrosion, and like I said previously, when we've got infiltration, we run the risk of overloading our sewer systems. It increases the costs to treat our waters because we're treating stormwater as opposed to just sewage. We run the risk of backing up our sewer systems as a result as well. And with exfiltration, we have that raw sewage going in, potentially seeping its way into our groundwater. And again, when severe infiltration is left unmanaged, all the surrounding dirt can be sucked in and through that manhole and eventually lead to a full collapse around a manhole. So now I want to talk about some of our more common rehabilitation options, including the traditional dig and replace. We'll start with discussing spray liners. These are typically epoxies, polyurea, or polyurethane sprays. I think it's important to note that these are not structural, and importantly, they are not embedded into the concrete. They are simply sprayed on top of the concrete. Another important factor is that for these to function well, they have to be applied properly. And it's been documented time and time again that often they're not applied consistently or properly. All it takes is one tiny pinhole for corrosion to begin again behind the structure. Oftentimes it's found that these require reapplication every few years, especially in a very turbulent manhole. And there's a lot of criteria that must be met for a good application to have occurred. Low humidity, control of surface moisture, and those can be hard to meet. Furthermore, there's no good solution for the inverts that have been corroding and eroding away. Next, we have cementitious mortars. These often do have a good chemical or acid resistance because of the additives that are added in that cement. But these, just like the spray liners, their longevity is very much impacted by the person who is doing the installation and who's completing that prep work. This is a very heavy product, and while it can provide a structural rehabilitation, it can also fall off the wall if that prep work is not done properly. And it too can require reapplication in just a couple years' time if not applied properly. It can also be difficult at times to create a smooth finish. And again, any pinholes left in that mortar will result in corrosion continuing behind that new liner. Furthermore, they can trowel down some of the mortar to try and recreate the inverts, but we have no good solution. They're not able to restore to the original dimensions, so we don't have the best of hydraulics, and you run the risk of solids potentially aggregating. Next, we've got thermoplastic sheet liners. HDPE has been the more common liner on the market, and the liner itself does have pretty good chemical or corrosion resistance. One of the things I think is important to point out is while they say it's a trenchless rehab, it really is not a true trenchless rehab solution. You are having to dig a trench or a perimeter around your ringing cone section, and those later must be repoured, compacted, and have the pavement or asphalt replaced above them. Welding of the HDPE, you have to be mindful of the humidity in the environment. And this particular type of plastic is also sensitive to temperature. And I mention this because it means that you cannot create precise cuts and welds ahead of time and bring your prepared materials to the job site, because unless you have an exact temperature from one place to the next, you're most likely going to see a difference in the diameter or sizes of those pieces. Furthermore, and you can see from the picture, they don't offer a monolithic base solution. It is a pieced together base at best that's prepared on site. So I would be concerned again about the hydraulics that this system would offer, and the potential for solids to aggregate and potentially form blockages over time. Lastly, the cement that's used to backfill this liner is your typical traditional cement, and while that does meet requirements for a structural rehab, it does nothing additional to protect from chemical attack or corrosion. And then last, we've got the full replacement, and full replacement is costly. It can be costly because of the need to possibly dewater the area, possibly needing to stabilize the soil in the area. It's certainly not conducive to do in every environment. If you have a busy downtown area, you don't want to have to dig up and replace an entire manhole and have multiple lanes blocked off for many days. So just in general, it's more expensive, more complicated, and takes more time. It also increases the risk of potential injury to the people on site because of the presence of the heavy equipment required. So now on to Flexliner. Why choose Flexliner? First, this is 100% trenchless. The liner is made out of polyurea, which is flexible. As you can see from the image, our base can be folded and inserted directly through the cone of the manhole. We utilize Core Protect polypropylene for our riser and cone sections. This is also resistant to corrosion, infiltration, and exfiltration, as well as hydrogen sulfide and sulfuric acid. These sections also can be easily inserted through the cone. We utilize stainless steel sleeves that allow us to create gas-tight and watertight connections between the inverts and pipes. We scan each manhole prior to the production of liners via 3D scanning to ensure a precise solution for each manhole. This is a sustainable solution in that we're not designing something that is supposed to be replaced every couple of years. This is designed to last for decades. Our liner is meant to be installed quickly. Typical bypass time for the base only has to be in the range of 4 to 6 hours. We only have to stop that flow long enough to get the base in. Once the base is in and set, flow can be restored while the rest of the manhole is rehabilitated. And a typical manhole that is, say, 10 to 12 foot deep can be rehabilitated in less than 2 days. Furthermore, it only requires 2 individuals to do a rehabilitation of a manhole. And the last thing I want to point out is that only an individual or party certified by Predl is going to be installing a Predl Flexliner for rehab. Now I want to go into some of our other key features a little bit more. As I mentioned, we will do a 3D scan. So we digitize every manhole prior to the production of any liner. We scan the manhole from top to bottom, and this allows our staff engineers to identify potential issues that we can't see with the naked eye. Furthermore, they're able to create drawings and make specific recommendations as to how we can rehabilitate that manhole. These drawings, once they're approved by the customer, we're able to use these to create an exact negative of the base or the inverts in that manhole with our 5-axis milling machine that we can then spray to create the Flexliner for that manhole. Each aspect of our rehabilitation solution is engineered and precise to that manhole. There's many technical features to our Flexliner. So again, it's made of a very durable and corrosion-resistant, flexible polyurea material. The backside of the liner is coated with aggregates and it has integrated bonding strips. These help to ensure a superior bond between our mortar and the existing structure. We also have a transition strip of polypropylene that's integrated into the Flexliner. This allows us to easily connect the riser sections to the Flexliner. There's integrated non-skid or slip protection in the base as well in the event somebody has to go into that manhole at some point. You can see in the image our stainless steel sleeves. These are utilized to create a gas tight and watertight connection between the Flexliner inverts and the existing pipes. And this is very unique to the Flexliner and to our rehab product. I'm not aware of any other product that actually creates this type of connection. You can see from the image, we offer superior hydraulics to ensure the best flow of sewage through this base. And our Flexliner has a minimum thickness of 4 millimeters. The core protect that we use to line the riser section and cone section is made out of a durable polypropylene. Again, it can be non-destructively folded and inserted through the cone section of the manhole. The anchors are available in a 13 and 15 millimeter high height. There are 38 anchors per square foot. And our pull-off strength of our anchors or studs is over twice that of similar polyethylene liners. Additionally, we've got a really good chemical resistance with a pH of 2 to 12. And furthermore, we've got really good temperature stability with the polypropylene liner. Last is our flex grout. And our flex grout is highly specialized. It has good acid resistance, far more than that of your basic mortar, grout, or concrete. It's highly flowable. It flows almost like water. And that's important because it allows it to get into all the nooks and crannies, filling in all the voids in and around the base section, as well as filling in all those voids in the existing structure. It sets very quick. It creates an amazing bond between our liner and the existing manhole. It is shrink-free. And when I say it sets quick, we're talking a setting time of approximately 10 minutes. And it can withstand a load in as little as 30 minutes. Once our grout is fully cured, it has a PSI of greater than 7,200, and that far surpasses the ASTM requirements. Now I'd like to talk a little bit about a recent installation that was completed in Fort Erie, Canada, or a case study rather. So this was a manhole that had heavy corrosion and infiltration. The location of the manhole, if you look in the bottom left corner, you'll see a map inset there. The manhole itself was located very close to a river, between a river and a creek, but we were also very near a large river, the Niagara River, in fact. So it was an environmentally sensitive area. This manhole was about 12 feet deep. And it was leaning. It was leaning because of uneven settlement underneath the manhole. The upstream manhole was actually on the other side of the river. We had power lines overhead, which you can see. And this manhole itself was located in the middle of a very quiet residential neighborhood. And all of these pictures you see were taken from the site of the installation. So you can really see how close that manhole was to one of the bodies of water. So when we think about what it would take to do a dig and replace option for this manhole, we have to consider the significant environmental impact that would have. First, bringing in large equipment to do the excavation. That would have a significant destructive impact on the sensitive environmental area. It would also be very disruptive to the people living in that area because we were really just across the street from houses. Bringing in this large equipment into this tight area also significantly increases the risk of safety concerns to the workers. And again, with those overhead power lines, we have to consider how that further complicates excavating that manhole and also setting a new manhole with the large equipment. Furthermore, because of our location and close proximity to water, we would certainly have to dewater the area. And that could be with well points or whatever the preferred dewatering system would be. Additionally, we would have to consider stabilization of the soil, possibly with sheet pile. With the dewatering, we're obviously going to have to run pumps continuously. Those pumps are going to run off of diesel, which is a dirty fuel. We've also got to consider the bypass of the manhole. So again, if we're doing rehab with Flexliner, we have to stop the flow for 4 to 6 hours. But if we're doing a full replacement, we have to consider that that could be for a couple of days. And that bypass is going to have to be continuous for a couple of days. So again, generators and bypass equipment running for a few days with that dirty diesel burning, leaving a considerable carbon footprint throughout the process. Once everything's done, you've got backfilling and compaction with large equipment, and I can only imagine that a considerable environmental restoration would be necessary to restore that site. Now, with all that said, I want to take a few minutes and show you all a video that outlines this exact manhole being rehabilitated with Predl's Flexliner.